Good morning to all. My name is Dr. B. Sharath Babu, working as professor in the Department of Mathematics in Siddhartha Institute of Science and Technology, Puttur. Now, today I am going to discuss about the mean value theorems. To discuss about the mean value theorems, we can see some definitions of continuous function and differentiable functions. Now, see the definition of continuous function. A function f of x is continuous in the interval a comma b. That means if a less than c less than b, c lies in the interval a comma b. Limit extends to c f of x is equals to f of x c. That is called continuous function. There are two types of limits, left hand limit and right hand limit. See, the left hand limit is limit extends to c minus f of x, and right hand limit is limit extends to c plus f of x. Suppose if left hand limit is equals to right hand limit, then the function is continuous. Suppose if left hand limit is not equal to right hand limit, then the function is said to be discontinuous or not continuous. Now, the definition of differentiable or differentiable function. A function f of x is said to be differentiable function in the open interval a comma b. Then the derivative of f of x at x equals to c is exist or finite. That is, limit extends to c f of x minus f of c by x minus c is exist or finite. That is called differentiable function of f of x. It is denoted by f dash of x. The Rolle's theorem is which states that let f of x be a function such that it is continuous in the closed interval a comma b, and second condition is it is derivable in open interval a comma b, and the third condition is f of a equals to f of b. Then there exists a value it belongs to open interval a comma b such that f dash of c is equals to 0. For example, to verify the Rolle's theorem for the function f of x is equals to sin x in the interval 0 comma pi. So sin x is exists for all values of 0 and pi. So it is continuous function in the closed interval 0 comma pi, and it is derivable function in open interval 0 comma pi. And the third condition of Rolle's theorem is f of 0 is equals to f of pi. In this case, f of 0 sin 0 equals to 0. F of pi sin pi is also 0. So both are equal. F of 0 equals to f of pi. Hence, the conditions of Rolle's theorems are satisfied in this case. Then there exists at least one value of x that is belongs to open interval 0 comma pi. Hence, Rolle's theorem is verified in the function sin x. See another example. F of x equals to tan x in the interval 0 comma pi. So tan x does not exist at the point x equals to pi by 2. Since tan pi by 2 is infinity, so it does not exist. Hence, Rolle's theorem is not verified in this case. Now, the Lagrange's mean value theorem, which states that let f of x be a function, which says that it is continuous in the closed interval a comma b, and it is derivable in open interval a comma b. Then there exists at least one value of x, say c, belongs to a comma b, such that f dash of c equals f of b minus f of a by b minus a. For example, take one example, x cubed minus x square minus 5x plus 3 in the interval 0 comma 4. So here the given function is polynomial in x. So every polynomial equation is differentiable function. It implies every differentiable function is continuous function. So every differentiable function is continuous, but the conversation may not be true. So the continuous function may not be differentiable function. So in this case, this polynomial equation is differentiable function. So it is continuous in the closed interval 0 comma 4, and it is derivable in open interval 0 comma 4. Then there exists a value, that value c equals 1 plus root 37 by 3. It belongs to 0 comma 4 open interval. So hence the conditions of Lagrange's theorem are satisfied. So this theorem is verified in this function. The main theorem, Cauchy's mean value theorem, it states that there are two functions f of x and g of x be a function such that it is continuous in the closed interval a comma b. It is differentiable in open interval a comma b. Then there exists at least one value of x, say c, is belongs to open interval a comma b, such that f dash of c by g dash of c. Here g dash of c is not equals to 0 in this case. So its theorem is applicable only for g dash of x is not equals to 0. So f dash of c by g dash of c equals to f of b minus f of a by g of b minus g of a. For example, take some two functions, f of x equals to x cube and g of x equals to x square in the interval 1 comma 2. So here f of x and g of x are continuous in the closed interval 1 comma 2, and these two functions are differentiable in open interval 1 comma 2. So here g dash of x equals 2x. It's not equals to 0 for all x values of its open belongs to 1 comma 2. So hence the conditions of Cauchy's mean value theorems are satisfied. Then there exists a value c equals 14 by 9. It belongs to 1 comma 2. C value is approximately 1.55. So it lies in the interval, open interval 1 comma 2. Hence, Cauchy's mean value theorem is verified. Thank you, one and all.